Welcome to qnawire.
So we're doing chapter 18, problem 3. So for A, it says show for an ideal gas at temperature T that dVRMS over dt equals 1/2 VRMS over T. Okay, so to start showing this, we know that VRMS is square root of 3 kBT over the molar mass. So now from this, let's start applying derivatives. So dVRMS with respect to temperature. So this is the same as ddt of square root of T times what's left over, which was just 3 kBT or 3 kB over the molar mass. So now we can just apply the derivative to the first part, keep the constants out here in front. Applying the derivative to square root of t, it then becomes times 1/2 1 over square root of t. Awesome. So now we want to show it equals this right here. So how do we get that? First, let's figure out, we know that it needs to have VRMS in it, right? So how do we get an RMS out of this? So we can just take 3 kB over m times 1 over 2 square root of t. So we need a square root of t in the top, right? So let's multiply by square root of t over square root of t. And now we're left with square root of 3 kBt over m times 1 over 2t. Or this is actually just 1/2 times VRMS over t, because this is just right here, VRMS. Awesome. So that was the first part of A. The second part of A wants us to show that delta V RMS over VRMS equals 1 over 2 delta T over T. And it gives us an approximation to use. So let's start out with that approximation. VRMS is approximately dVRMS dt times delta T. So this is approximately 1/2 VRMS over T delta T, and this equals delta VRMS. So now we can just divide by VRMS and see that this is delta T over 2T. And that's exactly what we wanted to show. Awesome. So that was it for part A. Part B now asks, if the average air temperature changes from -5 degrees Celsius to 25 degrees Celsius from the winter to the summer, estimate the percent change in RMS speed of air molecules between these seasons. Okay, so the percent change is just given as this quantity, the delta change in RMS over the total RMS, and we already approximated this as delta T over T, so we can easily plug this in. So this is 1/2 times the change in temperature here is 30 degrees Celsius or 30 Kelvin, and the relative change was the temperature here. We're talking about the relative change from the initial, so we need to use the initial temperature, or -5 degrees Celsius. That's 268 Kelvin. Awesome. So we can just plug that in our calculator and see that this comes out to being 0.056, and that is 5.6% of a change. Amazing. We got there.